In this practical, we are told that you are provided with solid K. Solid K is here. Carry out the following test below. Write your observations and inferences on the spaces provided. It is advisable when you're doing a practical, you switch the flame to a luminous flame so that we cannot waste more gas. Of course, we're going to get there to the flame test. So that is a luminous flame. Let us get back to the practical. Place about 1/2 of solid K in a dry test tube. 1/2. 1/2 on a dry test tube. So 1/2, you can look at it. So 1/2, it's something like that. We are going to place it on a dry test tube like that. You have placed it, and then heat gently, then strongly. Test for any gases produced. For you to heat substances using a test tube, you need to use a test tube only. Don't use your hands because it can burn you. And now, after placing it like that, we are going to test for the gases produced using a red and blue litmus paper that are there. Now, we cannot test for gases when the litmus papers are dry. So what should we do? We are supposed to moisten them. To moisten a litmus paper, we use distilled water. So I'm taking the blue litmus paper and adding water to it like that. Then I'll place it inside my test tube. Then after that, I'll take the red litmus paper too. Make it moist, then place it inside the test tube, then I'll heat. So to heat substances, we use now an luminous flame. So we are going to heat. What you'll see is that there is a colorless gas that is leaving our solid, and it is cooling on the cooler parts of the test tube. A white residue is being formed. And now what is going to happen to our litmus papers? You can see we are waiting for the result. See what will happen. Remember, we heat gently, then strongly. Now it is time to heat it slowly so that the gas is going to be produced. You can look well. All the litmus papers have turned blue. So what is going to be our observation after this practical? Now look here. The observations are very evident. A colorless gas which cools on the cooler parts of the test tube. So I light that. Colorless gas condenses on cooler parts of test tube. Then the next thing, look at the litmus papers. Blue remained blue and the red turned blue. So red litmus paper turns blue, while blue litmus paper remains blue. Then, if you look down there, there is a white residue. So a white residue. So those are the 3 observations for you to get the 1 mark. And after writing them, after writing the 3 observations, now we want us to write the inferences. Let us start with the first observation. The first observation is a colorless gas condenses on the cooler parts of the test tube. That colorless gas that condenses and forms a liquid is a confirmation that this was hydrated. salt. So that was the water of crystallization. Red litmus paper turns blue, while blue litmus paper remains blue. This is a basic gas, and that basic gas is normally ammonium ions that are present. And then we have white residue. The white residue is to confirm the formation of anhydrous salt after removing the water of crystallization. So that is how you're going to take the observation and the inferences. Then now let us proceed to the second procedure. Now, second practical is place the remaining amount of solid K in a boiling tube, add 10 cubic centimeters of distilled water and check well. So place the remaining solid on a boiling tube. That is solid K. We have placed the remaining amount in a boiling tube, and then we're going to add 10 ml of distilled water. We have a measuring cylinder there. So we measure 10 ml like that, and we place it inside the boiling tube, and then we're trying to shake well. So after shaking, what you can see is that the solid has dissolved. It has formed a colorless liquid. So we say dissolves, forming colorless liquid. So when a substance dissolves, then we're going to say it is a soluble salt. The colorless liquid is a confirmation that we have the colorless cations or the colored cations, which are copper 2, iron 2, and iron 3 absent, which are the colored cations. Or we can just basically say that the colored cations absent, just like that. Now, what you can see here, we have divided them into 4 portions as the procedure was saying, and our instruction is that to the first portion of our solution K, we're going to add sodium hydroxide. So here is our sodium hydroxide that you're going to add some drops, dropwise, until in excess. So let me put it close to your camera and you see what will happen. When add some drops, if you look down there, there are some clouds that are forming. Those clouds are the ones that we call a white precipitate. Now, just look at them. When I add in excess, that precipitate starts to disappear. So you can see they are no more. So what do we say? White precipitate soluble in excess, all dissolves in excess. So that is what I've written, that it is a white precipitate soluble in excess, or you can say dissolves in excess. And here is a table that can guide you to tell the test for cations. I'm going to attach it at the end of this video. Now, when you have colorless cations after dissolving a given solution, and you add excess sodium hydroxide and you see a white precipitate that is soluble in excess, this is your inference: zinc, aluminium, and lead. We use an acronym of ZAP when you see a white precipitate that is soluble. So therefore here I'm going to write zinc ions, aluminium ions, and lead ions. They are the suspected ions. I'm not going to say present. The reason I'm not going to say present, it is because I'm not sure that all of them are there, but at the end of the experiment, I'm going to get only one of them after cancelling effect that is going to happen as I progress to other procedures as they are here in the next page. Now I get to the second page on this practical, whereby I'm told to the second portion. This is our second portion. To the second portion, I'm going to add about 1 cubic centimeters of sodium chloride. Now, this is my sodium chloride. As you can see, it is written sodium chloride. How can I measure 1 centimeter? This teat pipette is calibrated or dropper. I'm going to pull up to 1 there, just like that. So that is at 1. Then add it all inside my test tube. What are you seeing? No white precipitate. And that is what I'm going to write. No white precipitate formed. Now, what is my inference? Back to our table here, or chart. If you are adding any chloride like sodium chloride and you don't see a white precipitate, remember for the ions, the chloride ions that are insoluble include lead ions. So that is why we are not seeing the white precipitate, to confirm that this one is absent. Lead is absent. So therefore, we will say here, lead absent. Now the cancellation effect that I told you is here. Just look from the previous practical. If we look very well, here we have zinc, aluminium, and lead. Now for this case, we have cancelled lead. What are we remaining with? We are remaining with zinc and aluminium. Now let us get to the third test. The third test is telling us to the second portion, add aqueous ammonia dropwise till excess. Here we have the third portion. We are going to add aqueous ammonia. It is here, ammonium hydroxide. So we are adding it dropwise. Let us see, when you are adding it dropwise, what is going to happen? Just see. So, are you seeing again some clouds? Now that is a white precipitate. Now what about in excess? We're going to adjust in excess and see what happens. So it is a white precipitate that is insoluble in excess. So we say white precipitate insoluble in excess. Now what is going to be our inference? Now let us look in our table here. When we add ammonia, you see a white precipitate that is soluble. We mean that soluble means it is going to disappear, it is zinc. But if it is insoluble, we are going to have aluminium and lead. But let us look back here. So zinc has been removed because it is a white precipitate that is not soluble. Therefore, we remain with aluminium and lead. But lead is absent. Therefore, we finally realize that it is aluminium that is present. Then now get to the final procedure, whereby you are told to the second portion. Now this is not the second. Of course, there's some typing error. This is second, third, fourth. Now let us say this. To the third portion, add 3 drops of aqueous barium nitrate, followed by 5 drops of nitric 5 acid. So this is our fourth portion. We are going to add this barium nitrate. We are told that we are supposed to add 3 drops of barium nitrate. 1, 2, 3. I think you have seen some clouds. The clouds are white precipitate. Then add ammonia. The amount that we are adding is 5 drops. 1, 2, 3, 4, 5. So what happens to the precipitate? So it is a white precipitate. Let me add more nitric. White precipitate that is insoluble. Now these are the results this far. You can see after adding barium nitrate drops and then some 5 drops of nitric, the white precipitate did not resolve. So we are going to say here white precipitate does not dissolve on addition of nitric 5 acid. And the inference is, this is a test for anions whereby we have the sulfate anions. Why are we saying the sulfate is present? Remember, the sulfate is quite saturated compared to the sulfite. If it is sulfite, the white precipitate dissolves. If it is sulfate, the white precipitate does not dissolve. And that makes us to come to the end of this analysis on cations and anions. These are the results this far. Now we are going to progress to the final practical. We are now in our final part of this practical, whereby we are going to do this third question, whereby we are told you are provided with an organic substance S. So we have it here, solid S. Carry out the following test and record the observations and inferences in spaces provided. Place about 1/3 of substance S on a metallic spatula and ignite it with a Bunsen burner flame. So we are going to take our metallic spatula and place, here it is our spatula. I'm going to place 1/3 of this solid. This is it. We are going to heat. Now look at this flame. It is a luminous flame, but we should use an aluminous flame. For you to shift to the aluminous flame, just open the air hole. So we burn it and see what will happen. So we are seeing the solid is burning with a yellow sooty flame. That is the observation. Thank you so much for giving us that observation. So we write it here. That is the soot. Okay, if you want to see it. So here we say burns with a yellow sooty flame. When an organic compound burns with a yellow sooty flame, it shows that it is unsaturated. And the unsaturated organic compounds that we know, we have the alkynes, and the alkynes. These are the unsaturated organic compounds that burn with a yellow sooty flame. Then we proceed to the second question for this case. And our second question is, place the remaining amount of solid S in a boiling tube. Okay, add about 10 cubic centimeters of distilled water, shake well. Use about 2 cubic centimeters portions of the mixture obtained for test 1, 2, 3 below. Okay, so we have our remaining solid here. We are going to place it inside a boiling tube. So that is what we are told. Then after that, I've placed all of it as they have told me. I've not left any. Then after that, I'm going to measure 10 ml of distilled water like that and add it to my solid. They say that we shake well, of course we are shaking. Now if you see it has dissolved, of course if we were to be asked the observation, we'll say that dissolves in water. This is organic qualitative, whereby we'll say that dissolves, and then the inference it is a polar organic compound, but that is not the case. We are told that after doing that, we divide it into about 2 cubic centimeters portions for test 1, 2, 3 below. So again, we measure the 3 sections. We have measured. Finally, these are the 2 cubic centimeters portions, and we are progressing now to the rest. To the first portion, add sodium hydrogen carbonate. Here we have sodium hydrogen carbonate, and they're saying we add solid. So we are going to take our first portion and add this solid sodium hydrogen carbonate like that. What are you seeing? You have seen some effervescences, some bubbles, and I've had some fizzing. So you can write any of them, the one that you're comfortable with. So I'm going to say bubbles. Just like that. Don't stress yourself if you don't know how to write fizzing, or if you don't know how to write effervescences. You can pick one of them, and this is the test for acidity. So we are going to say there is the presence of an acidic organic compound, of which we know the acidic organic compound that we know is the carboxylic or alkanoic acid, which is written like this, or we can say H plus, present like that. So that is how we use sodium hydrogen carbonate to determine for the presence of acidity in a given organic compound. Then the next one, we are told that to the second portion, add 2 drops of acidified potassium manganate 7 solution. Acidified potassium manganate 7 solution is here. You can see the color is purple. So we have to talk about this color. What is going to happen to the color? We are going to add it into our third portion. So let us add some 2 drops. Some 2 drops. So 1, 2. One thing that you can see, immediately it gets into the test tube, it decolorizes. So what is our observation? Say purple, acidified potassium manganate 7 decolorizes like that. And what do we confirm? We confirm that remember, when it is decolorized, we mean that there is unsaturated organic compounds present there, which are alkenes and alkynes, and also alkanols can be tested using that. Then now we proceed to the third portion. Add 3 drops of bromine water. Now bromine water is here. Bromine water is brown in color. That is the first thing I want you to know. It can be yellow in color when it has been exposed to air for some time, but our main color here is brown. So we are going to add bromine water, which is brown in color. So 3 drops, 1, 2, 3. What happens? The brown color of bromine water disappears, but we cannot say disappear. Never tell us about disappearing. Say decolorizes. So say brown bromine water turns colorless or decolorizes, and this is to test for saturation again, whereby these are the inferences that we write, and that is some test for organic chemistry. These are the results. Thank you so much for following up with us. Bye.